Hello everyone, welcome back to my channel. My name is Piyush and this is video number 10 in the series Azure DevOps Zero to Hero. In this video, we'll be focusing on containers and Azure Container Instance. So without wasting any time further, let me jump into the GitHub repository and show you the agenda for today's video. Alright, so I am in my GitHub repository. I'm sure you would have the link by now. If not, you know where to find it. So I have scrolled down to the section where it says Day-10 managing containers with Azure DevOps, and the first topic will be what is exactly a container, and then we'll look into the difference between virtual machines and containers. So this will make it more clear, like why do we need containers and how it is different from virtual machines. Then we'll briefly discuss a few challenges with the non-containerized application, and then we'll look into Docker architecture. We'll containerize a sample to-do list web app written in React.js, and this Dockerization will be with the help of multi-stage Dockerfile, which is a production best practice of writing a Dockerfile, and it will have different advantages as well. So we'll discuss those benefits as well. Then we'll look into what exactly is Azure Container Instance, and then we'll use Azure DevOps CICD pipeline end-to-end written in YAML, and we'll use that to perform CI/CD into Azure Container. So without any further ado, let's start with the video.
Before we start containers, let's talk about how a virtual machine is provisioned. So you have your physical server that sits somewhere in the data center in case of a public cloud or your personal desktop. On top of that, you have an operating system that lets you interact with the physical machine, such as Windows or Linux. Then you have your hypervisor, which makes this virtualization possible. Now, what exactly is virtualization? Well, it allows you to run multiple operating system instances concurrently on a single computer. That means you can run Ubuntu, Fedora, CentOS all at the same time on top of your Windows machine with the help of virtualization. In case of a public cloud, your physical server over here is a shared hardware that is being used by multiple organizations and users at the same time. When you request provisioning a virtual machine through a cloud console, it lets you provision a guest VM on top of the hypervisor. But at the same time, other users and organizations are also using the same physical hardware underneath with a separate guest VM. Each user install binaries and libraries on top of it, and then your application. A virtual machine is a software emulation of a physical machine which allows multiple operating systems to run on a single physical machine. Virtual machines are also isolated from each other and from the host machine, which provides security and stability. Now, if we talk about containers, it has the same physical server underneath and host operating system on top of that, but instead of a hypervisor, it has something called as container engine. Well, container engine allows you to run multiple container instances on a single operating system kernel. It works the same way as hypervisor but for containers. As hypervisor is for running multiple virtual machines on a single operating system, container engine allows you to run multiple container instances on a single operating system. Container has a lot of advantages, like they are lightweight alternative to virtual machines with all the required libraries and binaries packed within. Containers share the host operating system kernel, which makes them more efficient and portable than virtual machines.
So let's start with looking at the build promotion challenges in the traditional way. That means before we introduce container into the picture, right? So let's say you had a dev environment where the code was working fine, and end-to-end testing and everything was working smoothly. Then you use that code to build using some build tool, Maven, Gradle, or any other tool. Then you promote the build to the upper environment, let's say a test environment. It is working fine there as well. But as soon as you promote the build to a production environment or a higher environment, it starts failing. There could be some issues at the application level or at the infrastructure level or at the configuration level, and it is hard to identify the root cause of the problem, and it takes a lot of time to actually troubleshoot the issue and to fix the issue. And this particular phrase we have heard a lot of time if we have worked in a production environment. The developer often complains, I'm sorry if you are a developer, but I had to say this, Developers often complains that it works on my machine, why it's not working in production. And this question has always been raised. And there is no straightforward answer to this, right? Because in most of the traditional environments, production, test, dev, all environments are built on different infrastructure. For dev environment, we might be using 2 servers without a load balancer. For test, we might be using 3 servers with the load balancer. For production, we might be using 20 servers and with a load balancer in front of that. Or there could be many other infrastructure discrepancies between these environments. So this issue often occurs that it works on one environment but the same code does not work in another environment. So this is the major problem that Docker or the container solves. The container images are immutable. That means it packages everything including dependencies, libraries, application code, everything into one single image, and you basically ship that image from one environment to another. So there is no dependency on the configuration or the environment itself. So if it is working in one environment, there are really less chances that it will fail in the other environment, right? And this particular problem will not be there. So developer will be happy, operations will be happy, everyone will be happy. Now let's have a look at the Docker architecture. So please do not feel overwhelmed with this diagram. I'm going to explain it to you everything, and it will be pretty straightforward once you start working with it. Once we create the Docker file, once we start implementing CICD, this whole diagram will be pretty clear to you. I'm pretty sure about that. Okay, so let's start with this. So you have basically 4 major components. First is a client. So this client on the left side, if you see, this client is nothing but the way you are interacting with Docker. So it could be either Docker desktop, it could be a Docker CLI, or it could be an extension within Visual Studio Code, anything that is helping you run the Docker commands against the Docker. Then we have a Docker host. Docker host is the actual environment, a virtual machine or an actual environment where your Docker commands are running, where the application is hosted. And whatever commands you are running, like Docker build, push, pull, run, anything, any Docker command that you are running, it's basically instructing Docker daemon to interact with the Docker containers, and it will basically make all those changes. Like it will pull those images, it will push those images to the repositories, it will run the containers for you. So everything will be done with the help of Docker daemon. So this is the actual worker who does all the things, all the instructions that is being passed by the Docker commands. Then we have Docker registry. So this is nothing but Docker image repository where you store all your images so that you can use it further in multiple environments, or you can share it across within organization, or if it is a public image registry, then it will be available to everyone. So these are the main components. So you start with writing a Docker file. So if you see over here, there is a Docker file. So you write the Docker file which has step-by-step instructions of what needs to be done and how it needs to be done, like what operating system to use as the base image, what commands to run, what all files, dependencies, libraries to be copied inside that image, right? All those files are the set of instructions written in a Docker file in a predefined format. And then once the Docker file is done, you run basically Docker build command to instruct Docker daemon to use this file and to build an image. Image is nothing but packaged version of a container. So you create an image with the help of Dockerfile. We'll see that once we Dockerize an application. I will show you how to create that Docker image and what is the exact process. But for now, just understand this. I'm trying to explain it. That is why I'm repeating myself. So once you have the Docker file written, you actually build the Docker image using the Docker file, which has all the instructions written. And once that image is built, you basically store the images locally. So by default, it stores the images for you locally, or you can push the image to a Docker registry. This Docker registry could be Docker Hub or any artifact registry, or in Azure DevOps, we also have artifacts, and there could be many other Docker based registries. So once that is done, and by the way, you push that with the help of Docker push command. So Docker build command is to build the image. Docker push command is to push the image to the repository. Then once the image is pushed, now you go to your environment where you want to deploy that image. You basically pull that image with the help of a docker pull command. You pull the image from the repository, from the registry, and then you run docker run command. So this docker run command is actually create the docker container from the image. So docker container is a running instance of a container. So docker file, then you build it, then you push the image to a repository, then you pull the image to the environment, then you actually run the docker run command to build the container, which is a running instance of the docker image. So this is the overall workflow of a docker container. So in the next step, I will show you how we can dockerize a file from scratch. Okay, so this is the sample to-do application that I will be dockerizing it first, and then I'll be using the same in the CI/CD pipeline. So I will also share this link in the description and like in the readme file as well in the day-10 folder. So you'll get it from there. So first what I'll do is I'll create a new project in my Azure DevOps. So I'll go ahead, click on new project, give it a name, day-10 containers. Okay, let's keep it private and I'll keep everything as default. Hit create. Okay, the project is created. Now I'll go to my repos and I will go here where it says import a repository and I'll click import and I'll enter the GitHub repository URL over here. So let me copy the URL from this repository, copy, and then gonna paste it over here, then hit import. Because this is a public repository, it won't ask you for credentials, so it will take a couple of seconds and then the repository will be imported over here. Okay, it says it's imported, so let me go over here and yeah, it is there. So now we'll create the docker file. So let me just do it right over here, click new and then file and give it a name. By default Dockerfile is with this naming convention, D capital and then F small, without any space, without any special character in between. Create. Now to create a Docker file, we need to understand the manual steps of building and compiling the source code from the scratch, because Dockerfile is nothing but we are actually converting the manual steps of compiling and building the code and packaging it with the help of Docker containers. So we need to know the manual steps before that, right? So let me just start writing the Docker file, because let's assume that I know what all steps are needed to actually build this particular application. So this application is written in React.js and I know I need package.json, package log.json file. Within the directory, I need the source code, I need the dependencies using npm and all those things. So I have all the steps with me. So I'm gonna write all the steps. I'm gonna explain it to you. What are we doing? And once that is done, I'll explain it to you why are we doing it. So I'll start writing with the basics. So first is we'll start with from. Let me zoom in a little bit. I hope this is visible now, right? So I'll start with from keyword, and basically here we enter the base image of the operating system that we need to use to build this particular Docker image. So let's start with the node image. I'm going to use node 18 and then I will use Alpine as the operating system. Now, Alpine, if you have not heard this name before, Alpine is a lightweight Linux-based operating system and it does not take a lot of memory, it does not take a lot of space, and your Docker file size will be also less and startup time will also be good, right? So that's why most of the application are compatible with it, and for most of the application we uses this particular OS distribution. Now in this Docker file we'll be using a concept of multi-stage file and I will explain it to you, but for now let's just consider this particular stage as installer. So this is the first stage and we'll use a second stage as well later in this, but for now the first stage, in this first line we are just using a base image which is based on Alpine operating system and it has node 18 already installed. So that's what we are using. And let's go to the next step. Now we need to initialize a working directory. So we write this keyword work directory and slash the name of the directory. Right? So this is nothing but changing the directory inside the container. So container will have this directory /app. So we are just doing cd/app at this time, right? Let's go to the next line, and now the next part is we'll copy the package.json file, right? So let's do this, copy package.json, and we'll copy it to the current directory, right? So this command will copy the package.json file in the current working directory, which is /app. So let's go down, and now we'll actually install the dependencies with the help of npm install, right? So if you are looking at the commands, from is to use the base image, work directory is to change the directory, copy is to copy the files, it is self-explanatory, and then we have run to execute the command or to run the command. So there we are using npm install. Now let's go down. Now we'll copy, after the npm install is done, we'll copy all the files, like all the files generated by npm install, all the dependencies and libraries. We are using this copy dot dot, that means we are copying everything to the working directory. Now we are doing run npm run build to actually build the application source code. I made a mistake, so this is how it should be. Run npm build, and then we'll use the next stage. So the next stage will use another image, which is nginx. This is what we need to run the application. So we'll call from nginx and the latest image, and then we'll call it a deployer stage. Now why we are doing this, I will explain you just in a bit, but let me just complete it first. So we'll use this image, and then we'll use copy from installer. We'll copy it from the installer stage, and then what we are copying, we are copying everything inside the app build user share. I'm sure this will be nginx html, this particular directory, right? So everything will be copied in this particular directory. Now why have we used this? Because when we ran npm install command, it generated some files. In fact, we generated a lot of files after that, which we don't need as part of the docker image, right? So this will unnecessarily occupy a lot of space, and this will make our containers slow, and the docker image size will be huge. So that is why we are dividing this into multiple stages, so that when we are using the next stage, which is installer stage, we are directly copying the files that we need as part of the build, and we are excluding all the irrelevant files, right? So that's why we are copying directly from the stage and into the nginx working directory. Okay, so this completes our docker file. Let me commit the changes, and then we'll try to build this file. Maybe we'll build this as part of CICD pipeline, but this is the multi-stage docker file that we have built, and I have already explained to you each and every steps that you need. It has some additional commands that we could use. Maybe we'll use that in the later videos. So it has entry point, it has a few other commands that we can use, but these are the main commands, right? So let me hit commit. Okay, so if there are any errors in this file, we'll fix it when we run the CI/CD pipeline. So which is what I'm gonna do next.
Now let's quickly see how container instances work, and then we will jump into the demo. Your development team packages your application along with binaries, libraries, and configuration into a container image. These images are then uploaded or pushed to a container repository. It could be a private repository such as Azure Container Instances, or a public repository such as Docker Hub. Then, using the Azure portal, you deploy these images from the repository to Azure Container Instances, which is a platform as a service. That means all the admin work such as upgrading, patching, and infrastructure management will be done by Azure for you, and you just have to worry about your code and containers. Azure Container Instances allow you to upload your containers, and then the service will run the containers for you without you worrying about the underlying infrastructure.
Okay, so now that we have dockerized the file, let me once again verify it. Actually, I made a few mistakes over here, so let me just quickly edit it. So it should be package star.json, so that it will copy the log file as well, and we don't need this. And over here as well, it should be the source directory, which is app build. So when you run npm run build command inside for a react.js project, so it will create this particular directory and store the compiled code in this directory, right? So this is what we are copying to the nginx directory to serve it, right? So now it looks good. Let me just commit this file, and after that we'll create the Azure DevOps CI pipeline. But before that, as a prerequisite, we'll create an Azure Container Registry. So if you go over here, you search for ACR or Azure Container Registry in the Azure portal, if I was not clear earlier. So yeah, it does not show anything with ACR. So let me search container registries. Okay, so here it is. Okay, now hit create. Okay, subscription, let me use the default subscription and create a new resource group, Day-10 demo. Hit okay, and give this registry a unique name. It has to be unique, not just for your subscription, but it has to be unique globally, right? Because you will be accessing your registry with this fully qualified domain name with the suffix as .azure.cr.io, right? So it has to be unique. So let me give this a name. Let me call it Day-10 demo. Okay, I hope no one else is using it, and I guess this is good. Now use the location that is closest to you. Fine. Pricing plan, let me use the basic one. Need, will upgrade it to the standard plan, right? Then let's go next. Networking. Okay, it says private access is only available in premium plans, so I will be using the public access for now because I'm using the basic plan. But this is what we use in most of the cases, the private access, so that it is not accessible outside your subscription or your environment. Encryption tags, that's okay. Now let's review and create. Okay, okay, registry is almost created. It will take maybe a couple of more seconds, and once it is created, we'll have to enable a few more settings, and we have to gather the access keys, and then we'll move on. Okay, so it's created now. Let's go to the resource, and over here on the settings where it says access keys, go over here and you enable the admin user, right? It will generate the username and password for the admin user, which will be using in the Azure DevOps pipeline. So this is the username, this is the password. Um I'm just gonna copy it from here, or maybe I'll copy it later on. So I'll just keep this page as open. So this is a username, and this is a registry name, the full registry name, and this is the registry name, Day-10 demo. So now that our registry is created, let's go back and go to pipelines. I will create a new pipeline. Okay, and Azure repos git. I'm doing this fast forward because I have explained this multiple times, so I'm not just repeating it now. So select the repository, and this time, like most of the times, we have started with the starter pipeline or existing pipeline, or we have used the template, multi-stage template. But for now, we'll just use this one, Docker build and push image to an Azure Container Registry, the second option. So this is what we're gonna use. Okay, on the right side, it will ask you to select the subscription so that it will create the service connection for you. So I'm gonna select this subscription, hit continue, and it might ask me to log in. So let me just log in with my credentials. So Prince as the biometric authentication. Okay, and I do the password as well. Okay, it has authenticated successfully, and now it should show me the container registry that I have created in this particular subscription. So Day-10 demo, which is just be created, and then you give this image a name. So let me call it to do app. Okay, and a Docker file will be there in the source directory, and the name is this is the default name. If you have used some other name, so make sure you update this over here. So this looks good. Now click on validate and configure on the bottom right side, and it will generate a template YAML for you and will make some changes in that YAML afterwards. So I'll just let it generate. All right. So the first few things are basic, like trigger on the main branch, repo itself. Then we have this service connection that was created for us with the help of the Azure subscription. Image repository is this, container registry is this. These are all the variables that we can reuse in the later section of the pipeline. We have Dockerfile path and the tag. Right. So first stage is build and push. Right. So before that, actually this is not the correct command that it generated, because we need some extra steps. So let me go over here which says steps, and over here we'll write a new step. With the help of show assistant, we'll create Azure CLI command for easy login, because we have to first authenticate with the Azure Container Registry. So let's search for Azure CLI, and this is the one. Click on that. Now select the service connection, click on authorize. Okay, it will create the service connection for you. Okay, so now select the script type as shell. Script path, let's use inline script, and let's enter the script over here. Let me just zoom in a little bit. So I'll enter the script ACR login hyphen name, and then name of the container registry. So we have already used the environment variable, so I'm gonna use this brackets, and let me copy the environment variable from here. Okay, over here, so it was container registry, I suppose, this one. So copy it and I'll paste it over here. Right, so this is our AZCLI login command. Okay, so let's hit add. Okay, there are some indentation issues. I'm gonna cut it from here, and I guess I accidentally deleted the variable from here. So it was container registry. Was this one? Okay, so I need to paste it as part of the first step over here. Okay, I'm gonna add it. Okay, now this task has been added. This will do the AZ login to the Azure Container Registry that we have created. Now we have to build the image. So to build the image, the command is there, build and push. It has the repository name as well, which is image repository to do app, and then the Dockerfile path. This is good, and then it has the container registry service connection details as well, and the tag as well. Okay, so tag is nothing but the build ID. I guess this is what it is. Let me just go up, and yeah, tag is build.build ID. So this is also good. Now we have created two steps already. One is we have authenticated ourselves to the ACR, and then we have build the Docker image. Now the next step is to create the Azure Container Instance and deploy the image into that to run as a container. So I'll create a new task for AZCLI again to actually provision the container instance and to deploy the container on that. So set this, and let me select the service connection that we have created in the previous step, and this time also we'll use a shell script and the inline script. Now let me just paste the inline script over here. So the inline script would be az container create, and then we'll pass some parameters such as the name was Day-10 app, let's call it that. And then the resource group name with -g, so it was Day-10 demo, I believe that was it. And then add the image name, We can add the environment variable as well. So let me choose the image name. First we'll pick the, it has to be the complete path. Container name, it should be dollar sign, and then inside the brackets, which is the container registry name, which is day10 demo.azure.cr.io, and then the name of the app, which is to do app, this one with the repository name. So let me copy the repository variable as well, and then the tag name was, we also already had the tag. So let me do this. I'm sure it will be visible now, but if it is not, so the command will be there in the readme repository. Now I have added the image name. Now the next is, we'll add a few more details such as registry login server, registry login username. So let me copy the commands and I'll make the changes accordingly. Right, so registry login server, day10 demo, this is fine. Registry login username, I'll copy it from here. Was day10 demo, this one is the same. Now I'll copy the password as well from here, and I'll replace the password. All right, and the DNS name label, this would be fully qualified domain name on which our app will be accessible. So this is what we have used, and I believe this is completed now. So let me just click on add so that it will generate the YAML from it. For that I have to put my cursor on the line where I want the YAML to be generated. So it has to be after this stage. So let's click add, and it has added the task. Let me verify it once again so that there shouldn't be any indentation issues or anything. Let me move this a little back. Registry username, registry password. We'll try to run it. If there are any changes that needs to be done, we'll do that. We hit any error. Okay, so there are few other variables that you can replace, such as container registry, this one. So let me just do that. All right, and this username can also be changed, but it's fine for now. So this is not really a good practice to keep your registry password or any password at all, even though it is in encrypted or encoded format. It's not a good practice to keep it within the source code, within YAML, or within the pipeline. So we basically use Azure Keyword for those purpose, but we have not covered Keyword yet. We'll cover that in the later video. So that is why I have kept it right like this for now. So our pipeline is completed, right? We have done the AZ login to the ACR. We did build and push so that the Docker container image will be built and pushed to the Azure Container Registry, which we have created beforehand. And then we'll create an Azure Container Instance by pulling the image from the registry with the help of registry credentials. Let's hit save and run, and let's see if we hit any error or if it gets successful. Okay, now let's go to the build. Okay, it says pipeline need permission, so let me give it the permission to execute the build. Okay, by the way, this step you can run in your self-hosted agent as well. We already have covered self-hosted agent in the previous video. I forgot to use that for this video. That's why I'm using the Microsoft hosted agent. But I would suggest, if you have completed the previous video, I would suggest to, use that for this video as well. Okay, while it is doing its work, I'm just gonna pause the recording for a few seconds and then we'll come back and see. So before that it failed, so let me see why it is failing on the build command. So it says Dockerfile parse error, copy require at least 2 arguments but only one was provided. Okay, so there is an issue at this particular step in the Dockerfile, line 5 where we are doing the copy. So let's go ahead and quickly have a look at the repo. Dockerfile 5 copy dot dot. Okay, I missed a space in between that, so let me space. So this is source, this is destination, then hit commit. Okay, now it should trigger the pipeline again. Let's go to the pipeline. So it did the checkout. Okay, now it is building the image. It has proceeded further after step 5, I guess. So let's see if it is able to build the image successfully. Now it is running npm install, which will take few seconds. So I'm gonna pause the recording now. Okay, now it has successfully built the image. So let's see. These are all the steps it performed. You can have a look at the logs to see what all things it has done to build the image. Once that is done, it actually pushed the image and added a build tag as well to the repository. Okay, so my image should be pushed to the ACR now, and it has completed all the steps, but it failed at the next step, which is to create the ACI. Now let's see what error it is throwing. It is saying that the following argument are required, which is resource group. I remember I added resource group in the command itself, but I guess there is some mistake with the command. So let me open the repo in the new tab. All right, and let's go to Azure Pipelines. And here's a command which says az container create name, then -g, which is the resource group name. So let me see if this is the exact resource group name that we have created. Resource group is Day-10 -demo. Yes, this is the correct one. Okay, let me quickly check the command. So az container create CLI. Okay, go down. Az container create hyphen. No, this is the container group. So az container create hyphen resource group, and then resource group name, then the name of the container, name of the image, and DNS label, and the few other things. So instead of -g, let me replace it with minus hyphen resource group. I guess this has been changed recently. I'm not really sure, but let me try doing that. So instead of -g, let's use this, and let me check the error once again if there was anything else. So in this, there was this error, and then it shows basically the command that you can use, and then it is also saying -name command not found. This shouldn't be the issue. Az container create and yeah, hyphen name should be good. So let's commit the changes and let me trigger it again. Okay, there was actually a silly mistake. There was some extra spaces at the end of the command. That's why it was not able to recognize -g or resource group and the name parameter. So I have removed that, and it is working fine now. And it is showing the command or this particular task as well as completed, and I don't see any error. So let me go to my Azure portal and see if it actually created the container instance. So I'll search for ACI container instances, and I do see my Day-10 app over here, which is in running state. So click over that, and let's go to containers. I see one container running, and you can check the logs from this particular tab. Okay, and there are some, because we have not done anything, this is just some on some verbose messages. You can also do SSH into the container with the help of this command, right? and all the events will be generated, like it pulled the image, it started pulling the image, then it pulled the image, then it started the container. So all the workflow of the Docker, you can see it over here. So now let's go to overview, and here is the FQDN, the fully qualified domain name, ACI demo Piyush 101, and then your region, and then Azure container. So it's a long name, just copy it, or you can copy the public IP address, open in a new tab. It is showing the Nginx page, but it is not showing the actual application. So I guess there is still some mistake in this. So let me go back, go to the container, and we can actually log into the container. So let's do that. Let's connect and connect from here as well. Okay, I am inside the sandbox, which is a part of the container. So let me do ls, and we actually have to look for the file, the build file. So it should be inside the app directory. This is the work directory that we have initialized. So let's go inside that. Let's go inside build, user, here, Nginx, and then HTML. I'm not sure if this is the app created by our application. So let me just cat into index. Yeah, this is a React app, but I'm not sure why it is not showing over there. Maybe it's taking some time to deploy the app. Let me hit refresh on this page. So this looks okay, but again, okay, so let me go to app, build, user, share, Nginx, HTML. So our files are here, which is correct one. Oh, wait. I guess I know the issue is. So it shouldn't be slash app slash build user share. It should be only user share HTML Nginx HTML. So it should be inside user share Nginx HTML. So now it is serving the default Nginx page. Now if you remember the step in which we have made these changes, like in which step we had copied the files from one directory to this particular directory. Yes, if you have guessed Dockerfile, you are correct. So we made these changes in the Dockerfile. So let me go to my Dockerfile, hit edit. So I added this path by mistake. I'll just remove this. It should be user share Nginx HTML. I'll just commit the changes, and when I'll unpause the video after the build is completed, after the pipeline is successfully deployed, you should see the changes in the web browser itself. So I'm going to pause the video now and I'll come back again. Okay, so the pipeline has been completed once again. I'm sure this will work this time because we have made the necessary changes to it. So let me go back to my app. I'll copy the FQDN and I'll open this in a new browser. So yes, finally our to-do app is now listening on port 80 of the Azure Container Instance, and it is running as a container. So if we make any changes, like let's say add some item and press 2, I can delete the items, I can edit this, and basically this is a fully functioning app, and you can make the changes. Once you make the changes in the source code, it will build the Docker container once again, and then it will do all the steps, and then it will push the image to the ACR, Azure Container Repository, with the new tag, which is the build ID, and you can basically deploy this image in multiple environments. And yeah, that's all about it. Right, thank you so much for watching the video. I hope you have learned something out of it and you would have enjoyed the video. So if you did, give it a thumbs up, share with your friends, family and colleagues, and if you are new here, don't forget to subscribe the channel. I will see you soon with the next video. Till then, take care and happy learning. By the way, if you have any questions, any comments, any queries, you know how to reach out to me. There is a comment section below, and I also have a Discord server where everyone is there to help you out. So do not hesitate to ask for help. We are here to help you. So thank you so much, and I will see you soon.